Welcome to our second webinar in our Sizeware Educational Webinar Series. I am Ed Chow. I'm Sizeware's VP of Business Development. I'll be the moderator today. First, I want to go over some ground rules. We've muted everyone for the webinar. If you have any questions, please type them in the chat window at the bottom of your GoToMeeting window. We'll be looking at those as the webinar goes, and we'll address those questions at the end of the webinar. We've only got 45 minutes scheduled for a webinar, so Corey will be presenting, and then we'll address the questions at the end of the webinar. Now I'd like to introduce our presenter, Mr. Corey Lee. He's beside me. Corey is an enterprise technology architect with over 23 years of experience in IT, in the IT enterprise space, primarily in the oil and gas sector. Corey spent 13 years at Doesnt Energy, where he worked on large enterprise projects such as desktop virtualization for geoscience and engineering workers. Corey currently works at an independent consultant firm, as an independent consultant for the Manteo group of companies, a cybersecurity and infrastructure boutique technology firm. So without further ado, I will pass the mic over to Corey, and I will turn off our video since you'll be looking at something much more interesting.
Thanks, Ed, and thanks for everyone for having me here today, and appreciate the opportunity to get in front of you guys and hopefully teach you a little bit about cloud computing. Let's go ahead and get started there, Ed, if we're able to. So just quickly before we move on, I thought I'd share one of my career highlights with the group. As Ed mentioned, I worked at Doesnt Energy for 13 years. One of my more favorite projects was enabling remote desktop for our what we coined our specialized workers, which was our geoscience and engineering groups. This was a pretty cool project in my mind because what it did is it freed up our geoscience and engineering teams to be able to work remotely from anywhere in the world, running very graphic intensive applications, most of which you guys would be familiar with, including Sizeware. And it just enabled a capability that hadn't existed for those type of specialized workers in the past. It was a pretty big success, and we enjoyed a lot of good feedback from our engineering and geoscience groups as part of it. The reason I bring that up is it was a quasi-cloud type of project we did, and that was, you know, in the realm of about 7 to 8 years ago, before, just as cloud was ramping up to be the next greatest thing since sliced bread. So it was a good project, and had a lot of fun working on it. And like I said, enabled a capability that those workers hadn't been able to do previously. So we can move on to the next slide. So while we get into what cloud computing is and an overview for the entire group, I thought we'd start with kind of how we got to cloud computing and talk about cloud computing model evolution. So as most of you guys may know, we started out with mainframes in computing. That was a really expensive solution, usually took up entire floors of buildings, was a first in, first out type of model. So those who got to the mainframe first were the first ones to get their results after the computation happened. And typically we were looking at physical accessibility, meaning I had to be somewhere in a room with a mainframe. We started evolving to things like terminals, but again, required me to be physically in the building and at a terminal. We evolved into what probably most people are familiar with, client-server computing. This was a little bit more distributed, didn't require necessarily for me to be in the same building. We had limited accessibility through things like VPN or Citrix, remote access, etc. One of the big challenges with client servers, it required us as organizations to make large capital expenditures. Excuse me. Worth noting, during the client server era, we had an evolution within it where we went from physical to virtual. So we went from, you know, the ratio of 1-to-1 when it came to back-end infrastructure into more like 8-to-1, 12-to-1. So we started to branch out and virtualize our compute workloads and making the most getting the most value out of our physical assets. The reason this is important is because cloud is primarily built off of virtualization, excuse me, and it played a key role in cloud becoming mainstream for us. So as we got to cloud, we started to see more of an on-demand type of role. So my organization didn't necessarily have to invest a large capital expenditure and wait the 8 to 12 weeks for IT to deploy things. So we get into computing as a utility, so to speak, just like we have water and gas and electricity in our homes. It was there for when I needed it. Quickly, I was able to quickly stand things up, and it changed our IT spend from CapEx to OpEx. So we went to an operational cost. We're now paying for compute per second, per instance, et cetera. And then finally, the cloud is built on the internet, and so it's always accessible, regardless of where I am. No longer tied into physical locations, and I can typically access my environment from wherever I am on the internet. Before we move on to the next slide, if you click there, Ed, it should bring up a couple extra points I want to make. So during client server, the beginning of it, we saw the early days of the internet. Kind of as client server evolved into its fullest mature state, TCP IP and x86 became the standard. Without getting too technical, the internet runs on TCP IP. There are a lot of other network protocols that were in play prior to this. And x86 is typically what most of us will use from a computing perspective. It refers to the processor models that are used in computing today. If you run Windows or Mac OS, these are x86 processors. And then finally, as we came out of client server and started going into cloud, the internet became mainstream. It became available for almost everyone in the globe, and it became something that we just take for granted, so to speak. Everyone was involved in the internet. We can move on to the next slide. So some drivers of change that caused us to move from client server to cloud, make it the buzz term that it is today. I touched on it previously, is access, right? So the internet became mainstream, and what that did was all of a sudden people all over the globe were connected. Not just people, but things. So what went from isolated networks back in the mainframe and early days of client server now became to a global network of people and things. We saw supply and demand of technology take off. So there's Dr. David Moore, who has Moore's Law is coined on the internet. And basically his theory was that computing process capabilities will double every 2 years. And we've actually seen that happen and actually speed up more recently. What that drove was what we call consumerization, and that was basically the ability for everyone to carry a mobile phone in their pocket and have as much computing power as we did in the early days of client server, and probably even more powerful than mainframes. And we saw a massive amount of data growth with everyone connected and everything connected. So our supply and demand model has changed in computing. And then finally, I touched on this previously, was for us to, as individual organizations, stand up computing capabilities and technology capabilities within our organization. We often had massive capital investments to make that happen, as well as our time to market for new solutions was no longer meeting the demand created by the supply and demand. And that was, IT projects typically took in the range of 8 to 12 weeks to deliver business capabilities. And so we needed to change our model. So we touched on that, how cloud is always available, on demand and ready for our consumption. We can move on to the next slide. So before we, dive deep into types of cloud and services that cloud provides, I want to make sure we understand that really what is cloud, right? quite simply, to simplify it for the group, it's basically we're running technology services over the internet. Now, we've been doing that in the client-server model, and if we had quasi-private cloud environment stood up our environment, we've been doing that with things like VPN and remote access with Citrix. And we've typically done that out of data centers that we've owned, managed, or leased ourselves. Basically, all cloud is, simplified, is running those services out of someone else's data center. So in this example I'm providing, I'm taking email out of my data center, and I'm going to use it as a cloud service from some other provider. So to simplify, probably the most common one is Microsoft Office 365. It used to be that most of us ran full-on Microsoft Exchange email messaging environments, meaning we owned the application, we owned the infrastructure, the network and servers, and the software that ran that. We've now seen a shift where Microsoft provides that as a cloud service. What it enables organizations to do is get rid of all that infrastructure that we needed to run it, simplify the management of it, and actually put all the compute processing into someone else's data center. So there are a couple ways that we can look at what cloud can provide us. If you click again there, Ed, one more time, please. we can pick and choose what cloud services we want to run out there. So in the second example there, I've taken a graphical application. We can use Sizeware as an example. And I've taken the entire stack that's required to run Sizeware and I've put it into someone else's data center to run it. Now I'm accessing that application over the internet, and I'm no longer running the required backend and application within my data center. So really simplifying it, it's basically taking your IT technology and services and putting it into someone else's data center, and leveraging either everything they offer from the entire stack, from the servers and network all the way up to the application, or pieces of that. We can go on to the next slide. So types of cloud. So we have really primarily 4 high-level types of cloud: private, hybrid, public, and shared. For the most part, all of us in O&G are going to deal with the first 2, private and hybrid. So I'll quickly touch on the other 2. Shared cloud would be if we partnered with another organization and shared the underlying infrastructure and resources together. It's a cooperative use. There isn't a lot of isolation in terms of security and or workloads. You might see a lot of universities type running those environments. Public is where everything is shared within an offering. If you want to think about it in terms of everyday use, things like Gmail, Outlook.com, those type of things are public cloud offerings where if Ed and I both have a Gmail account, we're on the same type of environment, same hardware, same software. Our isolation is basically our login base, so everything else is shared. Private clouds are where us as an entity, whether it's an organization, a person, etc., we own everything in isolation. So whether it's on-premise or off-premise with a service provider, the entire stack is ours, the resources are ours, and we're solely responsible for it. Hybrid is an extension of private where I will have a mix of on-premise and off-premise services. And a lot of organizations, particularly oil and gas, are going to fall into the hybrid model. So if you run something, if your organization today runs Office 365, for example, and you still have services such as, say, Sizeware or file shares on-premise, that would be considered hybrid. Now, underneath each of the types of clouds, we have cloud services, and these can be a bit tricky to explain. I'm going to use pizza as a service as an analogy. I've got my friend Homer Simpson in the bottom right corner. We all know Mr. Homer loves pizza, and without splitting hairs, I think we can agree that on the left-hand side here, you'll see the stack that is required to create a pizza, right? So we need things like our pizza dough, sauce, toppings, cheese. We need to put it into an oven, and then we need a table and a plate to eat it. So if we think about those, I believe it's 8 items, that's kind of what makes up a pizza stack, as we will. If we click ahead one slide. So when we think about applications, we have a similar type of stack that's involved. Not all applications would require each component of the stack, but for simplicity purposes, if we walk through, we need security, we need a network, we need storage, compute. We may have databases and integrations. Most applications have a web server front end, and then we have an application that is running. So when we think about migrating an application to the cloud, and as I had mentioned previously, there are always specific components that we can move, or we can move an entire stack. So when we think of as service with cloud computing, it all depends on what we're doing from the app stack perspective of which as service we fall into. If we see down the right-hand side, ways to eat pizza, we're going to make it from scratch. We're going to take and bake it from the grocery store, and we're going to have a delivery guy show up, and then finally I'm going to go to a restaurant to eat my pizza. And as we walk through each of the different as a service, you'll notice that each of those correlate to how we're going to consume our pizza. So if we can move on there. So make it from scratch, right? I'm going to build up the pizza dough myself. I'm going to make grandma's secret pizza sauce. I'm going to put my preferred toppings on it. This is how we handled IT and services previously in a client server type of environment, right? So I, as an IT guy, would stand up the security network, all of those layers to finally deploy Sizeware out to my user community. So that's the make it from scratch when we're thinking about pizza. If we move on to the next level as a service, it's called infrastructure as a service. It's basically taking those 4 bottom layers and putting it into someone else's data center and running it that way. So this is the analogy we make with pizza is we're take and bake from the grocery store. So someone's gone ahead and actually built the pizza for me. I now need to take it home and stick it in my oven. So it's a little bit less from a little bit easier, if you will, from making it from scratch. I don't have to worry about the dough and the sauce, toppings, and cheese. Those are all provided to me by someone else. What I do with those is up to me. Moving on to the next level, it's called platform as a service. So this is where a lot of software developers will play. Not necessarily, doesn't necessarily align to a lot of oil and gas applications unless you're doing a lot of in-house development, which has evolved a little bit in the oil and gas industry, I'll say. And this guy's a little bit more like pizza delivery, right? So I've got all of the components of the stack up until the table and plate, right? So I'm going to have some guy show up at my door, and from there I'm going to go ahead and start eating my pizza. But what's key here is, I still need to provide a table and plate, basically the application itself. If we move on to the final one, this is software as a service. This is probably the one we're most familiar with on a day-to-day basis. So this is just me going to a third-party site and subscribing to an application. So I had mentioned Gmail earlier. This is Gmail, is a SaaS offering, software as a service. You can notice, you'll quickly notice that every single component of the application stack is now being managed and run by someone else at somewhere other than my own location. All I'm doing at this point is eating the pizza, or in this case, consuming Gmail. So when we think about cloud, we need to be careful around a few things, and we'll touch on some of the good and bad. And I should have prefaced this entire slide deck, but this is my take on cloud computing. Sure, if we wanted to split hairs and argue over a beer, there's some things we can definitely get into in the good and bad of cloud. So if we go ahead and progress there, Ed. The first thing is there's a lot of call it misnomers out there about cloud cost. You'll hear people say that it's cheaper. You'll hear others say it's more expensive. And the truth of the matter is it can be both. What's really important when we think about cloud computing and cost is that we are considering, we take into consideration the fact that cloud computing is a utility. It is often billed by the minute, sometimes by the second. And so we need to be a little bit more intelligent about our application workloads and how we put them into the cloud. If I have an application workload that sits on premise today and I decide to quote unquote lift and shift it to the cloud, my user community and myself for that matter as an IT resource, we're used to having that service on 24/7, 7 days a week, 365 days a year. That is typically how we run applications within our internal environment. When we move something like that to the cloud, the cost point of that becomes quite challenging. As I mentioned, because things are billed by the minute or even to the second, we need to rethink about what workloads actually belong in the cloud and what belong on premise. The other point I want to make here is as we look at our internal workloads and we decide whether they need to be migrated to the cloud or not, oftentimes lift and shift or taking clouds as they, applications and services as they sit today in our environment and moving them into a cloud environment without very good negotiation tactics, you will end up spending more on that application and service by just basically picking it up and moving it to someone else's data center. And the last piece I'll mention is it cheaper? It is cheaper, especially if you're a startup. So we talked about large capital investments and time to market and things like that. When you're a new startup looking to enable services and applications, quite often starting in the cloud is the best way to go because it gets you there quicker and you're building an app from scratch and you can build in things like turning it off and turning it on at appropriate times. And you're not being inundated with a massive utility bill at the end of every month when you do something like that. We can move on. Another very key thing and very pertinent to this audience is networking matters. So no matter how big of a back-end infrastructure Microsoft or Google give me on the cloud, we are still limited to how much and how fast we can move things across the internet. Bandwidth is something we should always consider when we're looking at adopting cloud services with our organization. Bandwidth is basically the size of our internet pipe. How much can we actually fit through that pipe? If we think about it in terms of a highway, you know, the more lanes we have, the more flow of traffic we're going to have. The less lanes we have, the more bottlenecks we will have. I do want to touch on latency. Latency is the round trip of our networking packets, and latency is limited to the speed of light. So, you know, unless we overcome limitations with the speed of light in terms of physics, latency will always be a thing we need to consider in terms of our experience with cloud applications. When we're looking at moving apps, it's very important that we consider we move the data with those applications. Some things we've seen in some of the oil and gas organizations that have gone all in with cloud is some of their higher end geoscience or engineering applications that require data actually perform worse in a cloud environment because they didn't move their data. So I have a rule of thumb when you're thinking about apps and services, regardless if you're moving to the cloud or not, the data locality matters to the application, and it's something that you need to keep in mind as you look at a cloud journey. You also hear things like cloud means less people, right? We can get rid of IT if we go to the cloud, Ed, right? That is absolutely not true. In fact, you're probably looking at a new set of skill set that your employees or your IT staff will require. At the end of the day, we still need IT resources to be able to manage our applications, manage our infrastructure in the cloud, and importantly, manage the security. Some reasons why we still need them, I touched on one of them already, is cost. If we just forklift all our apps and say, see you later, IT, we don't need you anymore, who's managing your cost and your resource utilization in the cloud? Just want to make sure that we understand that cloud doesn't mean less people. It doesn't mean we don't need IT anymore. There are certain cloud services that maybe put less of a demand on our IT resources, but they are still needed at the end of the day. A prime example of this is organizations that had a team of email administrators, let's say in the 2000s. As they went to Office 365, the early concepts were we could get rid of our messaging team. And, that's not true at all. You still need IT resources to manage your email, make sure it's secured, make sure you're protecting your end users. Email is the number one, email and web browsing are the number one vectors for cybersecurity incidents globally right now. So, we need to think differently about how our IT resources are leveraged and what they're doing. Security is a mixed bag, so it's good and it's bad. There's some things you need to know, like first of all, security it's not inherently included in cloud services. You still need to think about cybersecurity. You need to think about it in a different manner. I just mentioned one example of why security matters. If we move our email environment up to Office 365, it's still very easy for a bad actor on the internet to send Ed or myself an email that's malicious. That doesn't remove that layer of cybersecurity needed in our environment. I say it's a double-edged sword because we're also putting all our eggs in some major IT providers' buckets. So if we think about Microsoft, Google, and Amazon, the real big three out there, these guys are under constant attack from a cybersecurity perspective. So it's good to be aware that, look, just because I'm moving to Microsoft or Amazon that I'm protected. There is a level of some protection that's gained by looking at cloud providers, but the very key point here is that you still are responsible for your own cybersecurity when moving to the cloud. As I mentioned, Microsoft and Amazon and Google are attacked probably by the second, to be honest with everyone. And they have full-fledged teams of security guys. So hence why it's good and bad. You can know that your provider has most likely got a cybersecurity team that's in the hundreds times what you would have as an internal enterprise. However, you still need to be cognizant of security. So that moves us into some of the more positive things. Innovation, as I mentioned, we're at a point now where so many people are connected globally on the internet that we can now start leveraging ideas that respond halfway across the world in a different industry that actually apply to our industry. An example I have of this is, a few years back at Devon Energy, I was pushed to go and look outside of the oil and gas industry and find out what innovative technologies were happening in the world that didn't necessarily pertain to oil and gas at the time, but how we could maybe look at changing those ideas a little bit slightly and leveraging technology to innovate how we eventually abstracted resources out of the ground. So I'm sure everyone on the call is familiar with a thing called Google Glass, right? Google Glass was originally brought to market as a consumer product. So for me and my buddies to use, whether we're at the bar or just having fun around home, Google Glass actually took a turn where they decided that it was no longer a consumer-based product and had more play in enterprises. And so from an oil and gas perspective, one of the things we started looking at was, how would we use something like augmented reality in the oil field? And then from there, we started branching out to people all over the globe in different industries to find out how they were using augmented reality, and then tying that back to our business. So the point being is that innovation is available when we're in the cloud, and when we're able to build things quickly and tear them down. We're able to try new things and not make a massive amount of money and time investment into it. And I touched on agility, so this is important, right? I've made comments such as 8 to 12 weeks for IT projects to come online internally in our enterprise. And that's not to take a shot at IT organizations within enterprises. That's just the reality of it. Most organizations have a limited set of resources, limited budget, and takes time to plan technology acquisitions, deployments, and configurations, right? All of which include us securing it, making it available to the end users. All of those things have to happen in the back end. And so if one of the major benefits of cloud, as I mentioned earlier, is it's always there, it's available. I'm able to stand up a Sizeware instance without going and purchasing hardware and waiting for it to be stood up in my environment. I can do this now in the matter of minutes or days versus weeks. And so when you think of cloud, it's, and I mentioned it earlier, it's a great place when we're starting something new, because we have the ability to turn it up, turn it off, start again from scratch quite easily. Whereas if I'm doing that in my internal enterprise and I make a massive capital investment that takes 12 weeks to get into the hands of my end users, and when it gets into the hands of my end users, they don't like what they see, that's a lot of lost time and money. Whereas the cloud, I could maybe stand that up in a day, find out that's not what Ed was looking for, tear it down, start again. And that concludes the presentation. Happy to answer anyone's questions.
I do have a question while we're waiting. You talked about, it's better to start new versus lift and shift. And you talked about costs in terms of, how much it costs per second, per minute. What about the effectiveness costs of going lift and shift? Because people have to change habits of how they're using the software, I'm assuming, the application.
Yeah.
What have you found with that?
Yeah, I think so. The concept of lift and shift, I'm not a huge fan of it. I think what I tend to guide some of our customers on is to, lift and shift will work, but we need to rethink how available the application is. There's a lot of change management in terms of how our end users use it and what their expectations are of the product. Lift and shift would generally people tend to assume that they can take what's on premise 24/7 by 365 and move it up to the cloud and save money. And in fact, you won't save money that way. You'll see your operational expenses skyrocket. I won't mention the names of a specific company, but a fairly large Fortune 100 oil and gas company did a lift and shift to the cloud. Their CIO got tired of waiting for the right things to happen in the organization, and they immediately went to $1 million a month bill from one of the major providers. Were they spending $1 million a month on all their data center and hardware and all of that? Probably not. And if we look at over a 12-month period, $12+ million US spent on their computing. That was a sticker shock to them. So, if you're going to lift and shift, perfectly doable within the cost savings, but expect change management with your user community. And then when I say it's a great place to start something new, because it comes down to the ability to turn it off and on, tear it down easily without large capital investments. So for example, if I wanted to start a new application and I stood up a little bit of computing in the cloud, I could be looking at a $200 bill for 2 days, right? Great, shut it down, it didn't work. $200 is a lot easier pill to swallow than $1 million a month, right? So.
And I just want to reiterate a point just from oil and gas perspective. You mentioned earlier just the importance in terms of latency of making sure your data is with your application in the cloud, and I think that's really critical.
Yeah, it absolutely is. So, I mean, I've had some conversations with some people at Sizeware just about how to position cloud discussions with their customers. And, that's the first thing we talk about is where is the data going to be? If your data isn't going to reside by your app in the cloud, you will have painful moments. I mean, we've seen this even with client server applications that are split across data centers, never mind the cloud, right? One thing your IT team can't really change is the speed and availability of the internet. We're at the mercy of everyone else when it comes to that. So, when I talked about bandwidth, you can have a lot of bandwidth and then get on the internet. If 10 billion other people are consuming the bandwidth at that time, your experience isn't going to be that great, right? So we really want to limit what we're sending across a wire in terms of distance. These cloud provider data centers are spread out across the globe. Sometimes you can negotiate with a Microsoft to stay to the nearest data center. Other times you can't. So we really have to take into consideration how much and what we're sending across the wire.
I just saw a question come up. What is the level of cloud adoption for oil and gas companies, specifically around geoscience apps?
I'd say that's probably been the largest pain point when it comes to cloud adoption in oil and gas, primarily because of what we just talked about. The data sets need to be close to the applications. Further challenging in the G&G space is the requirement for high-end graphics. And so within the last 10 years, we've started to see technology that makes virtualizing high-end graphics possible. And that goes back to the project I mentioned earlier where we were able to free up our geoscience and engineering teams to be able to do things remotely. That just was never possible from a graphics perspective. That's gotten a lot better. So you're starting to see more success there, but it's still a work in progress, I'd say. It's primarily due to the size of data sets that you guys deal with.
Thanks again for your time. Really appreciate it. And thanks to Corey for his time.
Thanks for having me, guys.